Okay, hi everyone. What is the limit of this sequence? Okay, well, let's first of all, let's call this, I don't know, x sub n. And so what is x1, what's x2, what's x3, what's x4? Let's sort of get a sense for this sequence. x1 is 1 minus 1 over 1 plus 1, 0. x2 is 1 over 3. x3 what's x4? 4 minus 1 is 3. 4 plus 1 is 5. What's x5? 5 minus 1 is 4. 4, 6. I think we can see how it goes now. 5 sevenths, 6 eighths, 7 ninths, 8 tenths, 9 elevenths. Eventually we'll get to like 10,000 and seconds. And it'll keep going. And so you'll see that these numbers are getting closer and closer to 1. And so part B says prove. Okay, part A, the answer is 1. Now part B says prove that the answer is 1. Prove that. In symbols we would write this, but in words, the sequence x sub n equals n minus 1 over n plus 1 converges to its limit. In the previous video we may call this w, but in this video it's just the number 1. Okay, so proof. Okay, so the first step of a proof is that we have to say, what does the thing we're proving even mean? Okay, and I mean, I guess we could write what's the theorem? The theorem is that this sequence converges to 1. Okay, so proof, we first have to say we need to show, explain to the reader, what do we need to show? We need to show that for all d, there exists a cutoff index, such that for all the indices past the cutoff index, if we're past the cutoff, that implies that, I think it's x sub n minus w is less than d. And in this particular case, that just means n minus 1 over n plus 1 minus 1 is less than d. We need to show that for all d. So how are we going to do this? Well, we need to show it for all d. So let an arbitrary d be chosen. Now we need to show, we need to find capital N. Okay, and how are we going to find capital N? Well, let's look. We want capital N so that this thing is true. And so now I'm actually going to stop my theorem and just going to play around. I'm going to play around with this expression. This is the thing I want to be true. So over here, I'm going to do some calculations. And I'm going to give them a name, star, because I'll probably use the result of these. So first of all, x sub n minus w less than d becomes, that's just by definition of this problem, the limit is 1, and the sequence has that formula. D has been given, it's arbitrary. This is true if and only if, and now I'm just going to play. I don't know what's going to happen, but I know that 1 could be rewritten. Right, so this line is true if and only if this line is true, if and only if this line is true, if and only if. And now they've a common denominator now, so I can subtract. I get a minus n and a minus 1. The n and the n cancel, and the negative negative stay around, so I get negative 2 over n plus 1. And that's if and only if. I'm just rewriting. These are just sort of abstract calculations. And now here's the thing. I would like to write if and only if n plus 1 less than d. Then I can get rid of these annoying absolute value signs. Okay, and the price I pay is that a negative 2 should become a 2. And then I have to realize that this if and only if here is true, since little n is coming from the natural numbers, so n is positive. Okay? And so this denominator is a positive number, so it doesn't need to change. It doesn't need to become a minus or anything. The negative 2 becomes a positive 2, because that's the definition of absolute value. Okay, if and only if 2 less than d times s upon n plus 1, if and only if 2 over d is less than n plus 1, if and only if 2 over d minus 1 is less than n. So the thing I want to be true will be true if and only if this is true. Now notice, no matter what d, what specific d has been chosen, whatever number d has been chosen, it has to be positive. This whole thing will be some real number, and I can find a number bigger than it. No matter what d has been chosen, there is some capital N natural number such that capital N is greater than 2 over d minus 1. No matter what d is, I can find a number bigger than 2 divided by d minus 1. Okay, I hope you agree with this. If not, this is maybe coming from something called the Archimedean principle that you should look up on Wikipedia. And don't take the Wikipedia's page too seriously. I think we all agree. This is sort of one of our common, we're okay with this. There is some natural number bigger than this. Okay. But then, if a little n is bigger than capital N, then little n is bigger than 2 over d minus 1. And now I'm sort of ready. So let's bring this over to my proof. We need to show that for all d, there exists a capital N such that this is true whenever that we're past the cutoff, whenever little n is past the capital N. Let an arbitrary d be chosen. We need to find capital N. No matter what d has been chosen, there is some capital N with this being true. It's bigger than whatever this number is. But then, if little n is bigger than capital N, then also little n is bigger than whatever that number is. But that is true if and only if xn minus w is less than d. Or in other words, if and only if n minus 1 over n plus 1 minus 1 is less than d. And why is that true? By my calculation star, which I put here. But then, we're done. But then this shows that the sequence x sub n converges to 1. End of proof. Okay, this is a fun proof. I think it's easy enough, it's hard enough so that it's not entirely obvious. That's not obvious at all how to do this. I mean, these calculations, you don't really see them immediately. But if you just start taking the thing you're going for, your goal, your aim, then playing with it. If you play with it for long enough, you might recognize something that that is useful. Okay, and so the more examples I give, the more this will make sense. But for now, try to quiz yourself. Can you prove this theorem on a blank sheet of paper without looking? What's the theorem? This sequence converges to 1. Proof. And really do it in detail. Actually explain it, explain it, explain it. Refer to calculations when you need to. Keep explaining. Make sure your reader can follow your logic. Yeah, and you can use words, pictures, formulas to do it in your own voice.